What if math teaching could feel as clear, structured, and effective as teaching reading? Well, there's a powerful approach that is missing in math education today. It's what I call structured numeracy. In this video, you'll learn what it is, why it works, and how it can transform teaching. Welcome, I'm Becky Lord, your go-to guide on how we can align math instruction with neuroscience so that everyone can learn and love math. If that's what you'd love to learn more about, then hit subscribe and stay tuned because we're going to share a lot more content to make our math teaching mathemagical. If you'd like to go deeper, check out our free resources at lordmath.com, as well as our online decoding math course and our new structured numeracy curriculum called Mathemagical. Ready to create math confident kids? Let's get into it. So what is structured numeracy? Well, similar to structured literacy, structured numeracy is an instructional approach that focuses on explicitly and systematically teaching all the essential components of numeracy, including the foundational skills, in a highly structured manner. If you haven't heard of it much before, structured literacy is a term coined by the International Dyslexia Association to talk about what effective reading instruction is based on the science of reading. The first component of structured literacy is phonemic and phonological awareness. So we know from reading that students need to be able to understand the sounds of language before they can then map them to letters. In math, the parallel to that is called subitizing and groupitizing. So if you haven't heard of those before, subitizing is our innate ability to just see a small amount and know how many it is without needing to count. Generally up to about 4 items, although depending on the arrangements, you can maybe see 5 or 6, particularly if you think of like a dice arrangement. So groupitizing is then combining 2 or more of these subitizable amounts into a larger number. So for example, if you picture a 5 dice pattern and another 5 dice pattern, we can groupitize those together and quickly identify that that's 10 without counting. So perhaps we call this subitizing and groupitizing awareness. We know from the science of reading that phonemic and phonological awareness is an essential foundation. And in math, subitizing and groupitizing awareness is the essential foundation and it's what is most missing. Many schools have started to do quick images and subitizing tasks, but we're not yet using it as the foundation for how we develop number sense and how we learn all our math facts. The second component of structured numeracy is what I call the visual grapheme connection. So if you think about reading, you may have heard of phonics. So phonics is where we take the phonological sounds of language and map them onto the letters. So a sound grapheme connection or a sound symbol connection. In math, we want to take those subitizable and groupitizable visuals and map them to the numerals that represent them, the symbols. So the visual grapheme connection is where we map the visual of the quantity to the symbol so that the symbols become meaningful. Otherwise, you can hear the word 7, you can see 7 written as a symbol, but if you can't map it to a visual in your mind of the quantity of 7, then that symbol and that word 7 may be meaningless, which is what happens for many students if they don't have strong enough visual groupitizing abilities, subitizing, groupitizing, to be able to visualize the quantity. Okay? The meaning of number is really in the visual. So when we want students to have a strong visual in their mind when they're looking at symbols and have those all mapped well together. I want the visual of 7 to be mapped to the word 7 and to the symbol 7. And in order for the brain to actually be able to visualize a quantity of 7 all at once, it needs to do it in a subitizable manner. A random scattering of 7 dots is not possible for the brain to image and visualize all at once. But when we group it into perhaps a 5 dice pattern and a 2, or a 4 and a 3, so smaller subitizable amounts, now your brain can visualize those and put those together. The third component of structured numeracy is effective visuals and manipulative. So if we want for structured numeracy to be effective, and math learning to be effective, we have to use the best visuals and manipulatives. There are a lot of visuals and manipulatives out there, but a lot of them encourage counting. We want to use visuals and manipulatives that are set up to really help students develop the subitizing and groupitizing ability and not be overly reliant on counting by ones. So there's certain tools that I like to call power tools, which work so much more effectively than many of the other tools we often see in math instruction. So my favorite tools, number 1, is dot patterns. So the dot cards, dice patterns, any dot arrangement that allows students to be able to subitize and groupitize it visually and effectively. Another great tool is Cuisenaire rods. Cuisenaire rods are excellent for helping students be able to model and visualize. And again, you can't count by ones to know Cuisenaire rods. So the students need visual input on the size of number, and Cuisenaire rods help to provide that. But they're varying lengths, and kids can see the relationships between numbers as they model. And you can model everything from basic numbers, addition, subtraction, multiplication, fractions, algebra. They're a really powerful tool. I also love base 10 blocks. I particularly like to use the larger one. So I'll use the Cuisenaire rods for ones, and then the base 10 I'll use for hundreds, thousands, and extra of the orange 10 rods to supplement Cuisenaire rod orange 10 rods. And my last favorite tool is a number balance, which if you haven't used it, is a great tool for understanding equality and balancing equations, which can be a challenging skill for students to understand. So it's a really powerful tool for that. So another component in structured numeracy is it needs to be systematic instruction, which means that there's a system. And so all of the skills and understandings we want students to develop are sequenced intentionally. So students will learn the foundational building blocks first, and then quickly build on those skills to higher level skills. And so I like to imagine this like a tree branching. Once you teach a skill, now you can branch off and to go a couple different directions with it. So students can actually be developing and working on multiple skills at once. But you can't have a tree branch that just grows out of thin air. You have to have the foundational skills and then you build on it. But if you use what's called vertical acceleration, you can take the basic concept and actually build it and generalize it to multi-digit numbers, to whatever your grade level topic may be, okay, to fractions, to decimals, to integers. Okay, so systematic instruction means the sequence is very intentional. So we're also going to avoid the situation where students are surprised by having a problem show up and that they've never learned how to solve. It's similar to literacy. We want words to be decodable. We would teach, there's a sequence to how you would teach the sounds, and you would build it in complexity. And then the work the kids are doing should have just the sounds that they've already learned and are working on. So that's what we want. And so we're going to be very intentional about the sequence and to build on that. So kids develop confidence and they can, as they learn a new skill, now they're going to start to use that as well. The last component I want to talk about is explicit instruction, which is sometimes hotly debated in the math world, but explicit really just means that it's clear. The opposite being implicit, which means not clear, not clearly stated. And so we want our instruction to be clear, particularly for students who have some learning difficulties. It's essential that they get very clear, structured instruction on number sense, on developing the subitizing, learning numbers, learning effective math fact strategies based on conceptual understanding and good visuals. So explicit just means that we don't leave it to chance that students, or we don't let them just, hopefully they're going to get it. We're going to make sure, we're going to be very direct and clear that they understand what we're asking them to do. And we're still going to give them a chance to explore, but we're going to make sure that the instruction is clearly laid out for them. And so we get them, just like in reading instruction, we would very directly, explicitly, and clearly provide them the instruction on how to read. But then certainly we're also going to have them in read books, right? Write, explore. Okay. And in math, we're going to do problem solving as well and explore, but we're going to make sure they get all those clear facts learned well. All right. Well, that wraps up my introduction on what structured numeracy is. I hope that helps you understand this and it maybe lights up some ideas about ways you can improve your math instruction. If you'd like to learn more, please check out us at lordmath.com is where you can find all this information. There's links below. Also, please hit subscribe and share this with others if you know someone that would be interested as well. Let's work together and let's make math learning for all. I'll see you soon.